Hello there, my name is Teresa Pierce and I work here at Auburn Valley State Park. Today I'm going to be talking to you guys about water power and how humans have used it for hundreds of years to make our lives easier. You see, technology is a wonderful thing and humans have been inventing new things all the time. There's technologies in your life that you probably couldn't imagine living without. To think of a few of them, maybe TV, cars, showers, even maybe a washing machine so you don't have to do the dishes. We're used to technology making our lives easier. But technology wasn't always digital or on a screen. Sometimes technology can be a really simple invention that makes a big difference. And one of the very first inventions that humans mastered to make a form of energy, long before electricity was even thought of, was using the power of water to make our lives easier. How would you use water to power something? Well, it's rather simple. You see, humans have lived near rivers and streams for thousands of years. And when you've got a rushing body of water, rushing in one direction, humans think to themselves, what if we could use that rushing stream of water to power something? To maybe do the work that we're doing ourselves. Maybe instead of grinding up grain to make flour by hand, we could get the water to do it for us. So humans started to build dams. And what is a dam? Well, you take a group of stones or wood and you block off the river or stream. And the water starts to build up like a pond or a lake behind that dam. When you open the dam, that water is going to come rushing out. And what if you can direct that rushing water towards something called a water wheel? Now this is a little mini model of a water wheel. And the way it works is if you pour that rush of the river over this water wheel, it's going to turn. Well, simple enough, it's just a turning wheel. What good is that going to do? But what if you could attach something to the water wheel so that as it turned, it did the work that humans normally did? And that's what humans did. They were always seeking new ways to harness the power of water. And today I actually made a little craft to show you how it works in a very simple way. And you can do this at home too. If you have a water jug and a cork and maybe a little bucket, or even if it's just something small that you can tape to a string, you can make this little craft to see how water power actually works. So imagine that you are a farmer living near a river back maybe a couple hundred years ago, and you want to use that river to power your mill. So like we talked about, you need to build a dam. You need to then channel that water to your water wheel, and that water wheel in turn is going to be connected to the machines inside your mill to do the work that would take dozens of people to do. So we've built a craft here that's a little example of how it works. So imagine that there is a river leading right up here, and we have a dam, and now it's time to release the dam. The water wheel isn't actually generating any power. What's creating the power is the force of falling water. So as water falls onto the water wheel, it begins to turn it. And as it's connected to, it can begin to do work, lift heavy loads, turn machinery, things that would take probably dozens of people to do, or horses or oxen. It makes your life so much easier. And I know that sounds like a really simple idea, but most of our technologies at the base of it comes from a very simple idea. And this began to make people's lives easier. Farmers could grow more grain, they could do more work. But there are limitations to water power. I want you to think of maybe one or two that you could think of. Off the top of my head, I could see a problem of what if there is a drought? What if there isn't a lot of rain and the river dries up? How are you going to work your mill? Also, what if you want to move away where there aren't any rivers or streams? And now you want to build a mill, but there's no river to work with? How are you going to work your machinery? So water power is a little bit limited, and that's where a wonderful technology called steam power comes into play. Now, as you probably learned in school, there are 3 states of matter for water. There's ice, which you guys see here in the wintertime. There is water, and of course, there is steam, where it is evaporated into a vapor. You've probably seen steam when your mom or dad is cooking in the kitchen, when you see it out of a pot or a kettle. But how could you harness that steam? Because if you look at the steam coming off a pot, it just almost just a little thicker than air, right? It's not strong enough to turn anything. It's not strong enough to do any work. But people were convinced that there was something that they could do to harness the power of that evaporated water. So this actually idea of using steam has been around for thousands of years. In Greece, a mathematician actually was coming up with ideas of using steam engines, but this was just theory. and it would take over 1,600 years before the first working steam engines were built. In England, a man named Thomas Savery had this idea of, okay, we want to use a steam engine. I want to build one that works. And he did. But it was a really early design. It had a lot of flaws. Some of those very first steam engines were just meant to pump water out of mines. But it's not very effective. In fact, it's less reliable than a water wheel. So it took hundreds of years. It wasn't until the mid-1800s that we began to perfect the steam engine. It was reliable, more powerful. In fact, steam engines that we began to install inside of mills were 4 times on average more powerful than water wheel powered mills. So the steam engine began to take over the world by storm and really is what fueled the Industrial Revolution. Well, what are some uses of a steam engine? Well, steam engines can create energy, just like the water wheel can. But a steam engine is a bit more complex and powerful, so you can use it in many more different ways than you can use a water wheel for. A steam engine began to be used to power trains, and cars, and boats, and even tractors. If you can imagine, in a farmer's field, you see this giant, loud machine clanking away with steam coming out of it, and that was one of the very early powered steam tractors. It's not quite as effective as, say, a modern car with gasoline, but it was an amazing new invention. Mills, factories began to be built with steam engines. And remember when I said that a problem with water power is if you don't live anywhere near a stream, you can't build a mill? Now that you can build a steam engine, you can go ahead and build a mill anywhere you want, so long as you have a source of water that you can collect out of a well. So we've learned of a lot of different uses for the steam engine, things to make your life easier. Especially in the 1800s, it was a big deal. But steam engines also have their dangers. I don't know, you've probably been by the stove before when something was boiling, and of course boiling water is pretty hot. It is dangerous. A steam engine takes water that is boiled, the steam, and then it pressurizes it. That is the difference between a steam engine and a boiling pot. Imagine you took a perfect lid, it didn't have any holes, and put it over a boiling pot and continued to boil it. Have you ever done that? Cooking pasta maybe on the stove, and you leave the lid on too long and it starts to foam over? Well, that's what's happening inside a steam engine, except you create a little hole and all that steam bursts out into one direction and you can make it do work, just like we used to do with the water wheel. But hot steam can burn you, it can explode if you're not careful with it. So back in the day when steam engines were first invented, they didn't quite understand how to take care of this. Today, all steam engines have something called a safety valve, and that is on the top of our steam engine here. This safety valve has a pressure spring. As the pressure builds up inside the boiler here of the steam engine, it gets prepared. And if there's too much pressure, if I don't let the steam out to go do its job and it's threatening to explode, the safety valve will shoot up and the steam will release, preventing any kind of danger or getting burned. But back in the day, they didn't have that technology. So steam was powerful, but it was also very dangerous. So it had its limitations. But how does a steam engine work? Well, as you know, we need water. So we're going to add water here to this metal thing that's called the boiler. Now you probably noticed there's an electrical cord attached to our steam engine here. And we were talking about power before electricity, right? Well, because back in the day, they wouldn't have used electricity to power a steam engine. This little thing here underneath the boiler is called the firebox. And even though this one is just for show, back in the day, there would be a big stove under their furnace. And you would put wood, you'd put coal, burn it, and as that burns, it's going to boil the water. Now, you do know fire is pretty dangerous, and we don't want to use fire inside our park here today, so we're using electricity to do the same thing that fire would be done back in the day. So we're boiling the water. As the water boils here in the boiler, it builds up that pressure we talked about. Once it gets built up, we're going to go ahead and release it. And once I turn this valve, steam will shoot down here and down to the piston. What's happening is a piston is sort of like, imagine a fist, and your fist is here and you push against this fist. But if you are able to punch stronger, this hand is going to move back, right? Well, that's what the piston is doing. As you punch with the steam, the piston is going to move back and then move forward, and steam builds up again and does it over and over. And as it does that, it's going to turn the flywheel, which is going to do the job that you've designed it to do. You could connect anything to this piston and flywheel and power it. You could power a mill, like we said, we could power technically a car, a train. This steam engine is designed to create electricity. And to this day, there are actually power plants that are powered by steam engine. I know that sounds crazy, but they're still around today. So we're going to actually show you today how we're going to use simple water, boil it, and with it, create electricity to turn on this light bulb here. Now here on the table we have a miniature model steam engine. It's important to remember that steam engines can come in many different shapes and sizes. But at the end of the day, they all have the same basic elements. And we're going to look at the steam engine that we have here today to show you how a steam engine works in detail. So as we talked about earlier, you have a firebox. And that firebox is where the heat and energy is created to boil the water that you have in the boiler. Now, you can power the firebox with coal, with wood, or with electricity, like our tabletop steam engine. But at the end of the day, it's creating energy to agitate the molecules of the water to turn it into steam. Now, once the water is boiling here in the boiler and it's turning into steam, we need to build up that pressure like we talked about. So we've got our safety valve here just in case things get too hot and we need to let some steam loose. We've got here, this is the whistle. If you've ever seen a train with the train conductor make a whistling sound, you can lift up or lower the whistle to make a whistling sound. And here is the steam line. So once we have enough pressure, once we know that we have enough power here, we can release the steam, we turn the valve here to let the steam down the steam line. And what that does is all of that force of the pressure is now being pushed down here. And once it gets down here, it is coming up against a piston or pistons. Now a piston is sort of like a force, a line that has tension on one end, but it's movable. And you can use the steam to push the piston, and once the piston moves, it rotates like this, it rotates the flywheel. Now, some steam engines are quite complicated, and they have many different pistons that are doing a lot of work, but like I said, this is a very simple one. So the piston here gets hit by the steam. This right here is what's called a governor, and the governor is really kind of cool. If you see our steam engine turning, you're gonna see the governor spinning, and these little things here are gonna lift up into the air. The role of the governor is very important. You see, if you have too much steam, it's just going to push the piston and get stuck. And it's not really going to rotate. It'll just be stuck one way all the way open. So we need it to open and close, because as it does that, that creates the rotating motion that we need. You see, push, close. We need it to turn on and off. The governor, as the steam pushes through and it spins, it begins to lift these two little things up. And as it lifts up, it shuts off the steam temporarily. Once the steam gets turned off, it drops down because it's no longer spinning. And once it drops down, steam starts pushing in again. So basically, the governor says, turn the steam on, turn the steam off, over and over again, so that you have a nice circular motion of the flywheel. And what is the flywheel doing? Well, the flywheel here is connected, as you can see here, by a cable, and we have our flywheel turning what we call our power plant. You see, we've got copper wiring here. As it turns, it is generating electricity, and we are using it to power a light bulb. But at the end of the day, the uses of a steam engine are varied. You don't just have to power a light bulb. Like we said, you can power a car, you can power a train, you can even power a steamboat to sail around on a steam-powered boat in the river, which used to be a lot more common than they are today. So steam engines, at the end of the day, are a very simple device. You're boiling water and you're directing that steam to do a job. It's exerting its force upon a piston, which is in turn helping to rotate the flywheel, and the flywheel is connected to whatever machine you are powering. That, at the end of the day, is all a steam engine is. So today we've learned a lot more about water power and its different uses, and how it made people's lives easier, and how it made human civilization change over time. But there are other kinds of reusable and clean energy sources. There's water, there's wind, there's horses, there's manpower back thousands of years. Many of the different sources of energy that we've used over thousands of years has helped change technology, and it's a sign of the times. So as you use your home today, you've got electrical power. Think of what new fun source that you could use to generate energy in your home.